Imagine a computer so powerful that it can solve problems in 2 minutes that would take our best supercomputers over 100 million years. That's not science fiction anymore. China just built exactly that machine, and it's about to change everything we know about computing, cryptography, and global power. Welcome to Curiosity AI, where we explore the technologies reshaping our world. I'm your host, and today we're diving into what might be the most significant computational breakthrough of our lifetime. China's scientists have achieved something that seemed impossible just a few years ago. They've built a quantum computer called Jiuzhang 3.0 that operates 10 quadrillion times faster than traditional supercomputers. To put that in perspective, if our fastest supercomputer tried to solve the same problem, it would take longer than the age of the universe. But this isn't just about speed. This breakthrough represents a fundamental shift in what's computationally possible, and it's sending shockwaves through governments, tech companies, and research institutions worldwide. Let me explain how this quantum beast actually works, because the science is as fascinating as it is revolutionary. Traditional computers, including the most powerful supercomputers, process information using bits that are either 0 or 1. Think of it like a light switch that's either on or off. Quantum computers are fundamentally different. They use quantum bits, or qubits, that can be both 0 and 1 simultaneously until they're measured. It's like having a coin that's spinning in the air, being both heads and tails at the same time until it lands. Jiuzhang 3.0 uses something even more exotic than most quantum computers. Instead of superconducting circuits that need to be cooled to temperatures colder than outer space, it uses photons, particles of light, as its qubits. The machine harnesses 255 photons in a complex network of mirrors, beam splitters, and detectors. What makes this approach brilliant is that photons are naturally stable and don't need expensive cooling systems. The Chinese team at the University of Science and Technology created an intricate optical maze where these photons dance through, creating quantum interference patterns that solve mathematical problems classical computers simply cannot handle. The specific problem they're solving is called Gaussian boson sampling. It's a mathematical challenge that becomes exponentially harder for classical computers as you add more photons, but quantum systems can tackle it naturally. The moment this achievement was published in Physical Review Letters, one of the world's most prestigious physics journals, the quantum computing world knew something historic had happened. This wasn't just an incremental improvement. It was a quantum leap, if you'll pardon the pun. Previous versions of Jiuzhang used 76 photons, then 113 photons. But jumping to 255 photons didn't just make the computer twice as powerful. It made it 1,000 times more powerful than its predecessor and demonstrated true quantum advantage for the first time at this scale. Independent researchers from MIT, Oxford, and other leading institutions verified the mathematics. The Chinese team even made their raw experimental data publicly available, a move that demonstrates remarkable confidence in their results. When you're claiming something this extraordinary, transparency becomes crucial for credibility. What's particularly impressive is how they solve the technical challenges that have plagued photonic quantum computers. They developed new types of detectors and algorithms that can handle the complexity of coordinating hundreds of photons simultaneously. Now here's where this story becomes about much more than just scientific achievement. China's quantum breakthrough has triggered what many are calling a new technological Cold War. The geopolitical implications are staggering. China has invested approximately $15 billion in quantum research since 2017. That's not just money. It's a coordinated national strategy involving universities, government labs, and private companies, all working toward quantum dominance. Compare that to the United States, which has allocated around $1.2 billion, and you begin to understand why American officials are concerned. Within months of this breakthrough, the U.S. Treasury Department expanded investment restrictions, essentially making it harder for American companies to invest in Chinese quantum technologies. The European Union launched a €2 billion quantum research program, explicitly aimed at achieving technological sovereignty in this field. This isn't just about national pride. Quantum computers could eventually break the encryption that protects everything from your bank account to military communications. While Jiuzhang 3.0 can't do that yet, it proves that quantum advantage is real and achievable at scale. The country that first develops universal quantum computers capable of running any quantum algorithm will have an unprecedented advantage in cybersecurity, artificial intelligence, and scientific research. China just took a commanding lead in this race. So, what does this mean for your daily life? The applications emerging from quantum computing are mind-boggling. Let's start with medicine. Drug discovery currently takes 10 to 15 years and costs billions of dollars because we can't accurately simulate how molecules interact. Quantum computers excel at simulating quantum mechanical systems, which is exactly what biological molecules are. This could revolutionize how we discover new medicines, potentially developing treatments for cancer, Alzheimer's, and other diseases in months rather than decades. Financial markets could be completely transformed. Quantum computers could optimize trading strategies, assess risk across thousands of variables simultaneously, and detect fraud patterns impossible for classical computers to spot. The competitive advantage for institutions with quantum access could be enormous. Materials science is another frontier. Imagine designing materials atom by atom, creating superconductors that work at room temperature, solar cells with perfect efficiency, or batteries that charge in seconds and last for years. These aren't fantasies. They're potential applications of quantum simulation. Artificial intelligence could leap forward dramatically. Machine learning algorithms that currently take weeks to train might complete in hours on quantum systems. We could see AI capabilities that make today's chatbots look primitive by comparison. But let's be realistic about the timeline. Jiuzhang 3.0 is incredibly specialized. It can only solve Gaussian boson sampling problems, not run general-purpose algorithms. It's like having the world's fastest Formula One car that can only drive on one specific racetrack. The Chinese team is already working on Jiuzhang 4.0, targeting over 2,000 photons. Meanwhile, researchers worldwide are pursuing different approaches: superconducting qubits, trapped ions, and other exotic quantum systems. The race is far from over. The biggest challenge remains error correction. Current quantum computers are noisy and unreliable. Building fault-tolerant quantum computers that can run any algorithm reliably might take another decade or more. But China's breakthrough proves that quantum advantage is achievable, and that changes everything. We're likely years away from quantum computers affecting your daily life directly. But the industries being disrupted first, pharmaceuticals, finance, materials science, and artificial intelligence, will transform the products and services you use long before you ever touch a quantum computer yourself. China's Jiuzhang 3.0 quantum computer represents more than a technological milestone. It's a glimpse into a future where the impossible becomes routine, where problems that would take classical computers longer than the age of the universe can be solved during your lunch break. This breakthrough demonstrates that the quantum revolution isn't coming. It's here. The countries and companies that master these technologies first will have unprecedented advantages in science, economics, and national security. The decisions being made today about quantum research, international cooperation, and technological governance will shape the next century of human progress. Whether this quantum future benefits everyone or creates new forms of inequality depends on choices we make now. As citizens, investors, and global community members, we need to understand these technologies and their implications. The quantum age has begun, and it's moving faster than most people realize. This has been another episode of Curiosity AI, exploring the technologies that are reshaping our world. If you found this deep dive into China's quantum breakthrough fascinating, make sure to subscribe for more episodes where we decode the science behind tomorrow's headlines. You can find detailed sources, links, and additional resources on our website at curiosityiHub.com. And if you're curious about other emerging technologies we've covered, check out our episodes on advanced battery technologies and artificial intelligence breakthroughs. Until next time, stay curious about the quantum future that's unfolding around us. The next breakthrough could change everything once again,